guys, in this short lesson we're going to be discussing about points and vectors within Unity, and this is part of the vector mechanism. So basically, to actually work with points, let's go ahead and create two game objects. So I'm going to jump to game object and go to 3D object and create a cube, and I'll actually create another cube in the scene. So each time we create a game object, we can see it has these points. So let's go ahead and reset these points, and for my cube 2 I'm also going to reset my point. I'll call cube 1, let's call this the target. Now we can move points based on their position in space. So right now I'm dragging my cube and I'll set this at 10 units away from the X position. So if this was a 2D coordinate system, to describe this point, our X position is at 0 and our X position is at 10 and our Y position is at 0. Now Unity has built-in vector 2 and vector 3, and basically the vector 2 is built for 2D space and vector 3 is built for 3D space. For instance, if we actually effect a change in our Z-axis, we won't actually see that change right here, but if we get back to our 3D viewport and actually set a Z-axis value of 5, we can actually push this away, or we can set this to -5 and pull the game object towards us. Right, so it's a bit further apart, but we can actually see it in that distance. So let's go ahead and just reset back our game object. So vectors are important because we can use vectors to specify the position of game objects in space, and we can change them using code. So let's go ahead and see how we can code a game object that can target another game object by just moving our vector points in space. So to do that, I'll just go ahead and create a C# script, and I'll just call that target. And I'll just open up target real quick. Also, what I like to do in my scene is just add a little pointers, and I'll select an icon for this, and I'll also click on my target game object, and I'll also create an icon for my target game object, so we can actually see this in our scene. Also, if we go to our game view, we can actually see these two game objects side by side. So let's just jump back to our scene view. So let's open up our target script. So the first thing I'll do is to create a public game object, so I'll be getting the other game object's transform. So right here underneath our class, I'll just do a public game object, and I'll call that game object target underscore me, just to target, get a game object we can target. So next I'm going to create a function, and I'll just call it void move to me. So let's just say move to me, just like that. And once I have moved to me, in my start method I'm going to do the move to me. I'm going to call our function right here. So the first thing I'll do is to create a vector tree to get our initial transform, and I'll take that away from our game object's transform. So to do that, let's just say vector tree, and I'll get my to me. Let's just call that to me, and we'll get our target me underscore me game object. We'll get the transform, and we'll get the position, and we'll subtract that from our game object, transform, and our position. Now this transform is for the transform of the game object that is attached to this script. And also what we're going to do is to set our target, our game object transform position. So we'll do our game object dot transform dot position, and we'll set that to add that to the to me transform position. So to get our transform position, and we'll add that to our to me position. Right, so we're not using any update, so we can actually go ahead and get rid of our update script. Let's go ahead and save it and jump back to Unity. So basically what we're doing is getting our targets transform, and we want our game object to move towards our targets transform. So what I'm going to do is to click on the target game object, and let's drag this script and drop it down here. And let's open up our target script and attach, drag in our game object and place our game object right here. Let's go ahead and clear our scene, and let's go ahead and test our game. So right now we can actually see these two game objects merged together, and if we actually go ahead and get rid of that scene, we can actually see our game object jump right back. So this is happening extremely fast. So let's see how we can modify this code to actually move closer to our game object. If you simply just want your game object to jump to that position, that's fine, but what we want to do is to just add a smooth movement. So let's go ahead and kind of change this entire script to something much more better. So in my project scene, I'll just go to my assets and I'll just right click and create a new C# script, and I'll just call that target underscore smooth, so I can just move that smoothly. So let's go ahead and open up target underscore smooth by double clicking on it. So right now I'll just be using the same, modifying what I have already existing right here. So I'll just go ahead and get everything right here up to the start move method. I'll just copy that and I'll just go to my target game object and I'll just paste everything right here. And let's just go ahead and quickly save that. So the first thing I'll do is to actually make this accessible. So I'll just do a vector tree. And I'll just call that to me, to underscore me. And so I don't have to necessarily call it the vector tree again in the to me method which we created right here. Also, I would like to create a public float move rate. So I'll just do a public float move underscore rate, and I'll set that to a value of say 150F. And also I would like to set a float unit, and this will be just a unit value of 1.0F. So that I have that float unit. In my move to me function, what I'm going to do is to actually divide this. So right here where I have my transform.position, let's just go ahead and drop that here. I want to smooth out my movement, so I'll just do a to me, and just I'll divide that by my equal to, I'll use a slash equal to my move rate, just so it can actually smoothen out that movement. Also, what I like to do is to create an update function. So I'll just go ahead here and say my void move update, just like so. And basically I want to pass this within my update function, so I'll just call it move update, like so. And I'll just take my transformed position and just paste that in my move update, like that. So next, what I'd like to do is to actually get the distance between my game object's transform and the target game object, which is this game object we called target me. And to do that, Unity has a handy function called the distance. So I'll just say float get distance equals to our vector tree dot distance, like so. And I'll pass in my game object's transform. So I'll do a game object dot transform dot position, and I also pass my target. Let's call that target me dot transform dot position also. So I'm getting these two values, and it's going to calculate that distance for me. So right here, if this distance is actually close to 1, so I'm just going to say if Oops, sorry about that, guys. So if my distance, so the get distance, is actually greater than the unit, that means it's actually close to each other. Let's go ahead and get our transform position. So that's why I have the script section here, and I just dropped that right here. So basically I want it to be moving smoothly to this position. So let's go ahead and we have this in our start method, and basically that's it. So what we're doing is getting the distance between our two game objects and then moving them at a slow rate by dividing that distance by the move rate, which I've specified a value right here. So let's go ahead and save this script and head back to Unity and attach our script to our target cube. And let's just go ahead and select our target cube and drag our target underscore smooth. And let's deactivate our first script and let's drag in our cube. And let's go ahead and save our scene, and let's quickly run our scene. So we can actually see our game object slowly moving towards the cube. If we actually wanted this to be much more slower, let's go ahead and double that amount by setting the value to 300, and let's go ahead and just play that. Nicely. So that's how we can set up a simple scene that allows our game objects to move or jump towards positions. We can actually use other methods or other means. We can even use a vector tree.normalize, but I'll just leave it here because we don't want this to be too complicated. Once again, thank you very much for watching, guys, and I'll see you in the next lesson.